Hello guys, now I'm going to start chapter 6. This is section 1, Introduction to Sequences. I want to start with one of the most famous sequences in math, which is called Fibonacci sequence. In 1202, Italian mathematician Leonardo Fibonacci described how fast rabbits breed under ideal circumstances. Fibonacci noted the number of pairs of rabbits each month and formed a famous pattern called the Fibonacci sequence. How is that sequence? So the first two terms of the sequence are 1, 1. So in order to get the next term, we always add the two previous terms. So 1 plus 1 makes 2, 1, 2 makes 3, 2, 3, 5, 3, 5, 8, and so on. So let's take a look at a couple of definitions. Here a sequence is an ordered set of numbers, and each number in the sequence is the term of the sequence. So 1 is a term, 3 is a term, 8 is a term. And a sequence may be an infinite sequence that continues without end, such as natural numbers, real numbers, whole numbers, and Fibonacci sequence, or a finite sequence that has a limited number of terms, such as the set has only elements 1, 2, 3, 4. There are only 4 terms, so that's finite sequence. This is the Fibonacci sequence, or the natural, whole, real numbers are infinite sequences. So what does sequence mean? Sequence is similar to functions, just the notation is different. In order to express sequences, we use subscripts. Here, for example, in Fibonacci sequence, the first term is 1, so the first term is expressed by using the subscript a sub 1. So a sub 1 is 1, second term is also 1, a sub 2, and the nth term can be defined as a sub n minus 2 plus a sub n minus 1, which means the term is equal to sum of two previous terms. So this is called recursive formula. We are going to talk about two formulas in this section. So the first formula is recursive formula. What does that mean? A recursive formula is a rule in which one or more previous terms are used to generate the next term. So like Fibonacci sequence, in order to get the following term, we need to use the two terms before them. So we depend on the previous terms to generate next term. This is called recursive formula. So let's find terms of the sequence by using a recursive formula. Here we are given the first term of the sequence and we are given the formula. So here is a sequence where I have to know the previous term in order to figure out the next term on my list. So the first term is given, formula is given. I'm asked to find first 5 terms. So a sub 1 is given. I'm going to find a sub 2, a sub 3, a sub 4, and a sub 5. How? By using the given. So you're just going to substitute negative 2 for a sub 1 here. So let's go term by term. So the first term is already given. For the second term, here we are going to substitute 2 for n. So when you put 2 for n, it's going to be 3 times a sub 2 minus 1, which is a sub 1. That's given as negative 2. So replace negative 2 for a sub n minus 1. So plus 2, which gives you negative 4. So notice, in order to get the following term, the next term, we are using the previous term. So let's find a sub 3 and sub 3. So a sub 3 will be found by substituting 3 for n. So 3 times a sub 3 minus 1, which is a sub 2, that is what we found in the previous term, which is negative 4. So let's replace negative 4 for it, and plus 2, which gives you negative 10. So in order to find a sub 4, you are going to replace negative 10 by a sub 3 here and evaluate it. So a sub 5 is 3 times a sub 3 plus 2. A sub 3 was, a sub 4 was negative 28, and here is the term. So here are first 5 terms, negative 2, negative 4, negative 10, negative 28, and negative 82. So let's take a look at another example. Similarly, the first term is given, the recursive rule is given. We're asked to find first 5 terms of the sequence. So, in order to find the second term, you are going to substitute 2 for n. So, 2 for n, a sub 2 minus 1, which is a sub 1, that's already given as negative 5. So, you are going to write it as negative 5 minus 8, which is negative 13. So a sub 3, substitute 3 for n. So a sub 2 minus 8, a sub 2 was negative 13. So negative 13 minus 8 gives you negative 21. A sub 4, so let's substitute 4 for n. So you have a sub 3 minus 8. So a sub 3 was negative 28. So negative 21 minus 8, which gives you negative 29. Similarly, the last one, a sub 5 minus 1, which is a sub 4 minus 8. A sub 4 was negative 29. So negative 29 minus 8 gives you negative 37. So it's pretty easy because we are already given the formula. We are given the first term. So by using the previous term, we generate our next term. So this is a similar question. The formula is given, first term is given. So in order to find second term, let's plug 2 back into the formula. So it is negative 3 times a sub 3 minus 1, which is a sub 2 minus 1, which is a sub 1. That's given as 2. So negative 3 times 2, which is negative 6. So in order to find third term, negative 3 times a sub 2, which is negative 6. So it gives you 18. A sub 4, negative 3 times a sub 3, which is 18, gives you negative 54. So, and a sub 5, negative 3 times a sub 4, which is negative 54, gives you 162. So, I think that's it for the questions are enough for recursive formula. So, we have another formula as I mentioned before. So, unlike recursive formula, in explicit formula, we don't depend on the previous terms. So in some sequences, you can find the value of the term when you don't know its preceding term. So an explicit formula defines the nth term of a sequence as a function of n. So we don't need our preceding terms, so we can directly find our following terms. So here, without given the first term, without given the previous term, we are given just the formula, an explicit formula, and we're asked to find first five terms. So it's like functions. It's like evaluating functions. What we are going to do is so simple. So we are just going to substitute 1, 2, 3, 4, and 5 one by one for n. So let's get started. So let's substitute 1 for n first. So a sub 1 is 3 times 3 to the power of 1 minus 1, which is 2. A sub 2, 3 squared minus 1, which is 8. A sub 3, 3 cubed minus 1, which is 26. A sub 4, 3 to the 4th power minus 1, which is 80. And the last term, fifth term, 3 raised to the power 5 minus 1, which is 242. Actually, it seems easier than the previous formula. It is just evaluating functions. Just notation is different. So similarly, you are going to substitute 1 for n. So it's going to be, the first term is going to be 1 squared minus 2 times 1, which is negative 1. The second term is going to be 2 squared minus 2 times 2, which is 0. Third term will be 3 squared minus 2 times 3, which is 3. And fourth term will be 4 squared minus 2 times 4, which is 8. And last term, the fifth term will be 5 squared minus 2 times 5, which gives you 15. And one more question. The formula is given. Similarly, we're asked to find 5 first terms. So substitute 1 for n. 3 times 1 minus 5, which is negative 2. So plug in 3 times, so 2 minus 5, which is 1. Plug in 3, so 3 times 3 minus 5, which is 4. So replace 4 by n. 3 times 4 minus 5, which is 7, and substitute 5 for n. 3 times 5 minus 5, which gives you 10. I think these questions are enough in order to understand the explicit formula. Now we are gonna do the reverse. What are we gonna do? Now we are gonna do the opposite, writing rules for sequences. So far we were given the rules and we were asked to find a few first terms. Now we are gonna do the opposite. In these questions we will be given the sequence and we will be asked to identify the pattern, identify the formula. So in order to be able to solve them, we need to know a couple of things. So we have 3 types of patterns. Our pattern is either linear or quadratic or exponential. So let's remember, if we have linear patterns, the first differences of the terms are constant. If we have quadratic pattern, the second differences of terms are constant, and if we have exponential patterns, the ratios of terms are constants. If we know this, we will write the rule easily. So let's try to identify the pattern here. So from 5 to 10 to 20 to 40 to 80 and so on. So what's the relation between them? So let's check differences first. So the first differences, 10 minus 5, 5, 20 minus 10, 10, 40 minus 20, 20, 80 minus 40, 40. First differences are not constant, so it is not linear. What about second differences? 10 minus 5, 5, 20 minus 10, 10, 40 minus 20, 20. Second differences are not constant either, so it is neither linear nor quadratic, so it can be exponential, so we have to check ratios. So 10 divided by 5, 2, 20 divided by 10, 2, 40 divided by 22, and 80 divided by 42. So as you see, ratios are constant. So we can say that it is an exponential pattern. So what are we gonna do? We are gonna write an exponential formula. So you know how to write an exponential formula. It can be written in the form of a times b to the power of x, right? A times b to the power of x. Your base here is 2 because the ratio is 2. So it's gonna be 2 to the power of something times a. What is a? A is the first term, 5. So a is the first term, 5. You're going to write 5 times base 2 to the power of something. What is that something? So we are looking for a to the power of n. We can generalize it as a to the power of n is equal to 5 times, first term times, base to the power of one term less than what we're in. So here we have n, here we're going to write one term less than n, so n minus 1. 5 times 2 to the power of n minus 1. So let's check if it is true. So our first term is 5, a sub 1 is 5. So it can be written as 5 times 2 to the 0. So see, the term is 1. Here we have subscription is 1, subscript is 1. The power here is 1 less than 1, 0. Here the subscript is 2, the power here is 1 less than 2, 1. Subscript is 3, the power is 2, 1 less than 3. So we can generalize it as a sub n is equal to 5 times n 2 to the power of n minus 1. So let's take a look at another example. Here, first we're gonna check differences, first differences, and then second differences, and then ratios one by one. So let's check first differences. So first differences are same. 4 minus 1.5, 2.5. 6.5 minus 4, 2.5. 9 minus 6.5, 2.5. So first differences are same. They're constant. So I don't need to take a look at the second differences and ratios. So it's enough. Now I know the pattern. The pattern is linear here. Since first differences are same, constant, so the sequence is, linear. So you know how to write a linear equation. It can be written in the form of mx plus b. mx plus b. So b is the starting point, which is 1.5 here. So you are going to write 1.5 first plus the constant difference 2.5 times one term less than the term. So 1.5 plus 2.5 times n minus 1. Here we are looking for a sub n. Here we are gonna use n minus 1, one term less than what we are at. So 1.5 plus 2.5 times a minus 1. You can distribute 2.5 to n minus 1. So it's gonna be 2.5n minus 1. That is what the explicit formula is here. So another example. Let's check their first differences first. 5 minus 7, 5 minus 7, negative 2. 3 minus 5, negative 2. 1 minus 3, negative 2, negative 1 minus 1, negative 2. So they're all negative 2. So first terms are same, constant, which means we have a linear pattern. So we are going to write it as mx plus b form. So your b is 7, the first term is 7. So a sub n will be 7 plus the difference, negative 2, times n minus 1. Here you are looking for a sub n. So on the other side of equation, you are going to use a term 1 less than n, which is n minus 1. So a sub n is equal to first term, 7, minus the difference, plus the difference, negative 2, times the term, one term less than n, so n minus 1. Do distribution here. You're going to simplify it. It's going to give you 9 minus 2n. And last example. So here we are given the sequence as 1, 1/2, 1/3, 1/4, 1/5, and so on. So as you can see, your numerator is all constant. Your denominator is increased by 1 for each term. So actually I don't have to check differences, check ratios. It's clear to me that when I give 1 to n, it is 1. When I give 2 to n, it's 1 over 2. Give 3 to n, 1 over 3. Give 4 to n, 1 over 4. So the pattern is 1 over n actually. So 1 over n is your explicit rule. So this is all for this section.